Chapter 3. In this chapter, we're going to be covering decimals. 3.1, Addition and Subtraction of Decimal Numbers. You know that whole numbers are written in some power of 10. The places are from left to right, ones, tens, hundreds, thousands, etc. A decimal number is a fraction whose denominator is some power of 10. 10, 100, 1,000, 10,000, etc. A decimal number can have a whole part and a fraction part. So the decimal number 324.576 expanded is 3 100ths plus 2 tens plus 4 ones plus 5 1/10ths plus 7 100ths plus 6 1,000ths. So you can see the denominators of the decimal part of the number are all powers of 10 in increasing order from left to right. So some examples of writing out decimal numbers. 0.6 is 6/10ths. When there isn't a number to the left of the decimal, it's usual to put a 0 there as a placeholder. 7.05 is 7 5/100ths. So the 0 is the 1/10th place. The 5 is the 100th place. So that is 0.05 hundredths. 7 5/100ths. 12.267 is 12 267 thousandths. The 7 is in the thousandths place. 0.0065 is 65 10,000ths. The numbers to the right of the decimal are called decimal digits. Most, if not all of the time, you will be using your calculator to add and subtract the decimal numbers, but when performing them manually, the decimals need to be lined up, and like powers of the numbers also need to align vertically. So as an example, if you were adding 13.2 plus 1.57 manually, you would put the decimals under each other and line up the places so that they align. 13.2 plus 1.57, 14.77. If you want, you can put a 0 after the 2 in 13.2 as a placeholder, so that you can line up your 7. You follow the same process with subtraction, and you subtract just as if there were no decimal. Application of adding decimal numbers. So here's an application. A sheet metal worker uses 2.36, 7, 3.9, and 0.6 fluid ounces of cleaning concentrate on successive jobs. What total amount of cleaning concentrate has he used? So you're going to add all of these numbers by lining up the decimals and the like powers of 10 and use zeros as placeholders to help align the decimal parts of the number. So you can see we've aligned all the decimals, and then we've aligned each of the places so that they are the same. The places are the same for each of the numbers. And when we add these, aligning all of that, we get 13.86 ounces. Here's another application for you to try on your own. If 0.037 inches of metal is machined from a rod exactly 10 inches long, what is the new length of the rod? So turn off the video, try this on your own, and then go to the next slide and see the answer. So you're going to subtract 0.037 from 10 by lining up the decimals and like powers of 10. Now you'll notice there's no decimal numbers in 10, so you have to use zeros as placeholders to the right of the decimal so you can align the numbers. You can also add zeros to the left of the decimal in 0.037 so that you can align the digits on both sides of the decimal. It does not change the value of 0.037. So aligning the decimals and aligning the places, we get 10.000 minus 00.037 equals 9.963 inches.